Okay. Hello everyone. So this will be our sixth and last workshop. This will cover how to slice 3D objects and turn them into machine code so that you can put them in your printer. So if you haven't already, these are the slides. I sent them inside the workshop chat. Also, you do need to download Prusaslicer. There is Cura, but for this tutorial, we'll teach you how to use Prusaslicer. It's mostly because the printer is in our place. We use a Prusa Mark IIs, so that's why we use Prusaslicer. In addition, they've recently adapted the Prusaslicer so that it now works with other printers, such as the Ender 3. And personally speaking, I like using it more than Cura now. So just a few things about 3D printing. So over here is like the hot end, and over here is like the build plate. So these things have like a specific temperature, and while you're slicing like objects, you can control like the hot end or the build plate depending on what type of material you're printing. So if you're printing with like PLA, then you would probably print around 200 degrees. I think it was, I forget if it was Fahrenheit or Celsius, but it was 200 degrees. If you're printing more of like PETG, you would go higher and go for like 240, maybe 260, depending on your printer. And also for build plate, there are like a few things, but generally speaking, it should just be around like 60 degrees. So how do you turn a 3D file into code for the printer? So, for this tutorial, we'll be using two things. We'll be using Among Us characters. You can download them from Thingiverse, which is in the slides. And also, there's a Chunky Pikachu that I designed. I remember I posted on Thingiverse, but I don't remember if it got through. So here's a raw file, anyways. But yeah. So when you're selecting your printer, you want to make sure you pick the Mark IIs, and you want to make sure the nozzle is 0.4 millimeters. The nozzle is pretty crucial because that's like the standard one that we use, and also if we're using a different nozzle, then we have to switch it physically. But this is what comes in stock. And then also you want to make sure that when you're selecting, when you're actually like working with Prusaslicer, you actually have like the correct one selected. So right now I'm using the Ender 3. That's because personally speaking, I have my own Ender 3. Okay, so first we'll import the head STL. So I guess I'll show you how to like download it too. I guess so. For here, I'll do download all files just because. Okay, and then we can see that in my folder. I already have a file. I was actually printing some for my friends, so I'm just gonna click on this, and then you go to files, and then here is the head. So you can just drag. You can also click up here to the add button. So if you click this add button, then you can go and select the head again, but that's okay. And then there are a few things that are important. So for navigation, there's moving the actual model. So over here, you can control the X, Y, and Z. So if I want to move it here and move it here, or if I want to move it up, that's fine. I think in the setting right now, I have it so that it always touches the build plate. So that's why when I'm dragging it up, it just like goes right back down. But that's fine. The reason why we have this is because if you weren't using it and you try dragging it around, it gets really, it's like really weird because it's like based off your viewpoint. As you can see, it like went all the way to the corner when I try to like put it at the center. It gets kind of funky. So then this is just for like more more specific tuning. And then next we have scaling. So sometimes you want your model to be bigger than what it is, or smaller. So then you can drag around like the X, Y, or Z. So and also this corner over here, like these four back corners, they're to scale the entire model like all three axes. So then you can make it like 300 bigger or smaller. You can also change the settings over here on the side. So then you can change the how much it scales, and yeah. So I'll just change it back to 100. And there's also rotation. So sometimes you may want to like rotate a model. I'll show that in a second, but like for now, if I wanted to flip this like 180 degrees, I can do that like that. There's a line to plane. So sometimes the model may come out in a weird orientation. So let's say it was imported like this, and you wanted to fix it so that the head was like so that this part was on the bottom. You can click on this face, and then it snaps back so that it aligns the bottom face to the bottom plate. And this is pretty useful when your imports are like in a weird order or like a weird rotation. And then there's post plane cut. It's pretty simple. It's just like a plane cut. You can drag it around anywhere, and then you can do perform cut, and it separates the two. Personally speaking, I don't really use this as much, but it's just there. And also to auto arrange parts. So this is kind of, or let me cut this 1 second. Cut it here. So right now it's in a weird orientation and it's overlapping each other. So to fix this, we can actually click on our mouse or on our keyboard the A button, and it auto arranges the parts. So then now it's like separated, and it's yeah. So now let's go import all the Among Us parts instead. So let me just delete these two, and then import. Just select all, click OK. And right now you can see that they're all overlapping. So what we can do is we can just click A, and then it separates all the parts so that they're not overlapping each other. And right now this isn't necessarily the best orientation, specifically with this bottom piece. If we go to adding supports and we do everywhere, we can click yes. Then if we click slice now, then what happens is the slicer does like it cuts the model up into layers so that the printer can print them. And right now there's like some weird supports over here. So actually I'm gonna make this full screen. So over here on the back of like the Among Us character, it's like it's sticking on the bottom of this part, and that's like a surface that we see. And typically speaking, any surface that's touching a support will come out somewhat more jagged and rough. So it's not necessarily the ideal solution. Over here with the bone and the visor, we're forced to do this because we don't have any other choice. If we were to rotate this like 90 degrees, so maybe like this way, and then we sliced it, then what happens is the part that we're looking at, which is like the front of the visor, is going to be the most jagged. It's going to be the most rough, and it's not going to be the most aesthetically pleasing. So before, how it was is just as okay. And then also with the visor, there's like a bunch of support here, but it's not very necessary because it's just a small like lump. It's not very like, it's not a big overhang that actually requires support, but we have it on anyways, and that's not ideal. So what we want to do instead is we want to adjust some of these parts and the orientation. Also for structural supports, or not structural supports, for functional prints, where the print is actually going to be used for like holding something up. Generally speaking, you want the force not in the direction of the layer line. So you don't want if this is like standing up, you don't want the force coming in this way, if that makes sense. And that's because it will like rip the layers off, and that's like the weakest point. So if you're designing something that's like for something functional, you want it so that the force is like going like up or down. And yeah, so let's go fix this print. So what we can do first is we can go back to here. Oh, I forgot to mention. So here, this cube part shows us like the actual models, like as if they were smooth, and the layer one shows how the model would be if it was cut by the slicer. So as you can see here, there's also like a bunch of like information on what type of materials you're using. This arrow thing over here, it shows us kind of like a timeline. So if we drag down, we can actually see the individual layers and how they're being printed. So you can see like we can see how it cuts like all the way in, and we can also see the infill pattern. But then yeah, so let's go fix this. So first, what we'd want to do, we just want to rotate this basically, or we can use align to plane. So let's do place on face, and then we click on this part. Then as you can see, it's like flipped upside down, and we can click A just to make sure it's auto arranged, and then we can click here to like slice it. And then over here, we still have the supports on the visor, or not the visor, the head, which is not very necessary. So what we can do is we can change our settings so that instead of having our supports everywhere, we'll just have it on the build plate. And if we click slice now, then it recalculates like the support areas, and it realizes that this part wasn't touching the build plate, so now it's not there anymore. And then also if you like cut in, you can see the supports that are inside the model. So yeah, and then some other important things. So this thing that's like this ring that's looping around like all these models, that's called a skirt. The reason why we have this added on is because for printers, usually when you start printing immediately, the plastic inside the actual printer may not be fully melted, if that makes sense. It might be empty because all the melted plastic leaked out earlier. So this skirt over here kind of ensures that there will be plastic flowing through the printer when your print actually starts, and also it gives a good indication of how big your actual print is. To change the skirt, you can go to print settings and then go to skirt and brim, and now we have like a few different features. Personally speaking, I like having like around 2 or 3 loops depending on how big my thing is printing. And also the skirt height, I just like to do 1. And then also we have this feature called a brim. So what a brim does, so if I add it right now actually, and I go back, so what a brim does, it creates like this this flat layer over here. Now what this does is that sometimes with prints, the plastic doesn't stick on to the bed the entire time. This could be because of like a difference in temperature, like maybe a cold wind blows on your print and it kind of makes the plastic shrink, or it could just be because of like some other reason. But regardless, what this brim does is it allows the print to like stick on better, and it ensures that all the edges around here won't like warp up and ruin the print. I guess a downside for this is that with brims, they're kind of sharp when you're taking them off, and you do have to smoothen the edge. Like I guess over here would be the circle, so that it doesn't cut, or it's not as sharp. Um, but yeah, and then let's see, and then yeah, we can do a layer preview. We can also change the infill settings. So if we go to print settings, and then we go to infill, we can change the fill density. So that's like how dense the inside material is. So if I did 0, you can imagine that this would actually be hollow. And it is. This isn't necessarily ideal right now, but it's something you could do if you needed to. Let's just change it back to 15. And then, oops, why isn't it 15? Okay, and then now we can do a fill pattern. So there's a bunch of different patterns. Personally speaking, I think, what was it? There's just like a few that you should use. There's like grid. Gyroid is good for like, I guess handling forces in 3 dimensions, if that makes sense. There's also cubic and line. Concentric if you're trying to save material, or if it's like circular objects. But yeah, so we can play around with the settings. So oh yeah, one more thing for the fill density. A good rule of thumb is that you would use like 5% for like cosmetic prints, 10% for like prints that are like probably if you're just leaving them out as like decoration, 20% if you actually want them to be like strong, and 30 is if you're actually using it to like hold something, because you don't want it when it's like 5% and it's holding something and then it breaks and then it ruins like the thing that you're holding. You don't want it to break, so around 30% is good. Anything higher than that is probably more wasteful than what you're 3D printing. You'd probably be better off just using a different material. But yeah, and then to play around with some other features with Prusaslicer, we're gonna be importing the Pikachu model. So I'm gonna delete these and add my Pikachu model. That one. And yeah, so right now, as you can see, the model is actually like really big compared to the actual bed size, and I don't really want to print another giant Pikachu. Like I already did it. One's good enough. So we can shrink this. So we could use the shrink tool or the scale tool and then shrink it down. But I guess if you want to be exact, then you can go to the sidebar and change the size to, let's say 60 millimeters. That's around like a desk ornament height. And then next, if we just slice it right now with supports everywhere. This is probably taking a while because the Pikachu is like smoothened. It's like, but this support is like okay, but if we like look in from the layer height, it's like relatively okay, but I guess this is just from my experience. If you print it with a uniform infill, what happens with this model is that it kind of leans back too much and it doesn't stand properly. It's mostly because of the center of gravity with the tail over here. So so we can fix this with slicers, and what we can do is we can actually import this thing. So if you let me go back here. If you right click on the model, you get this menu. And what we're going to do is we're actually going to change the infill inside the Pikachu on specific parts. And we're gonna make it so that we're gonna make sure the tail is slightly stronger. And then we're also gonna make sure the bottom part of the Pikachu is it has more infill so that it's heavier. So we can do add modifier and then box. And then now we have like this box thing. And what we want to do is whenever you're using a a modifier, a support enforcer, or a blocker, what you want to do is you want these things to overlap with the model you have in mind. So right now this is the modifier. So we're gonna move this towards the tail. It's probably around here, and then scoot it over here. And then we also want to rotate this, so we can click rotate. Oop, wrong way. Just kind of rotate it up so it aligns with its tail. Line it up. I want to get that tiny bit, so I'm going to rotate it again. Yep. And then I also want to highlight the tail, so I'm just going to copy paste this. And then drag this up. And then rotate it. And then scale it a little bit so it's a bit bigger. And move it. And yeah, so now we have the whole tail highlighted. So what happens with this print is that for the tail, it tends to break off because this portion over here that's connecting the tail to the Pikachu, it's very fragile. So I actually like to make this a little bit heavier than the top part. So what we're going to do is we're going to right click. We're going to right click and then we click infill. And then now we can change the setting for this modifier, for this block. So for here, I want it I just want the tail to be like 20%, or actually no, let's leave it at 15. We'll change the base one later. And then you can do the same thing here, right click, infill, change it as 15. We can also change the support if we wanted to. So we can change this to triangles. And same thing over here. And then now if I click slice now, it's like taking a while. Okay, so then now if I use the layer preview and I kind of zoom in, this infill is like more of like the triangles pattern rather than this one, which is like the grid. It's not as easy to tell because it's so like small right now, but we can fix this. So if I change this infill to actually like 5%, I'll click slice later because it takes a while, but it'll make it less hollow, or it'll make it hollower. So then now what we want to do is we want to make the bottom part of this Pikachu like more heavy. So what we can do is we can also add another modifier, and we can add a box. If you click on load, it actually loads another STL, and you could load a STL as like the modifier, if that makes sense. But I personally never use that part, so I just use like the box. So now we're just gonna make this cover like the belly or like the feet of its the feet of the Pikachu. So we just scale this, make it a bit wider, and then translate here. This is like okay, and then we're gonna change this infill, change the infill to, we're gonna make it 30 just because I want it heavy. And then just to show the difference, I'm gonna make it gyroid. And if I click slice now, it's gonna take a while. But yeah. And then also over here, so after this we're gonna show the support enforcers. So there may be parts on a print that don't actually show up on the slicer, and that's because you can decide, you can go in the print setting and decide how to at what angle threshold should there be support. Typically it's at 45 degrees. But like, yeah, so if I use the layer preview here, you can see this is like relatively sparse. And then once I like start cutting in more down here, you can see the gyroid pattern, so it's like super dense down at the bottom. So now this will like definitely stand, but we do want to fix the ears, because the ears, technically speaking, like if the slicer doesn't recognize this as a problem, but I guess like for my own sanity, I don't believe the printer will print this as well. So what I like to do is I can add a support enforcer. So if you right click and then do support enforcer in a box, you can actually move this up and rotate it, and then cover its ears. So if I do that, somewhere around here, it's okay. And then I can copy paste, drag that over here, rotate, and move it up. And then now if I click slice now one last time, what this is going to do is it's going to create support on its ears. And this kind of guarantees that the Pikachu's ears will have like a good amount of detail in it when it finishes. If it loads. Yeah, so then now as you can see here, the ears actually have the ears actually have supports, so now when it prints, it'll look out nice. And yeah, so I guess that's the end of my workshop. Thank you all for coming. But yeah, I think this is a perfect time to switch into project hours.
Awesome. Thank you, Ryan.
Oh.